Hello, I'm back again. We're graphing quadratic functions, quadratic equations still. Except now what I did was I put a number in front of the x squared. So this one is 1/2 and this one is a -2. And I wanted to do two at the same time because I thought it'd be fascinating. If there's no x term, not x squared, but if there's no x term in a quadratic equation or quadratic function, the value in the middle of your table is always at 0. So we'll do this one in brown, this one in green, and this one in blue. And the values to the right of 0 are 1 and 2, and the values to the left of 0 are -1, -2. And when I substitute them in, it's the same thing. Almost forgot. And when I substitute them in, it's the same thing, except the values don't work out the same way now. 0 squared times 1/2 is 0. 1 squared is 1 times 1/2 is 1/2, or 0.5. And 2 squared times 1/2, well, 2 squared is 4, and half of 4 is 2. And that works the same way. This is 0.5, and this is 2. Now for the blue one, there's a negative, and you do the negative last because you do exponents first, then multiply by -2. So when I substitute in 0, 0 squared is 0, times -2 is still 0. When I substitute in 1, 1 squared is 1, times -2 is -2. When I substitute in 2, 2 squared is 4, and 4 times -2 is -8. I'm going to go ahead and graph these really quickly. I'll do the brown one first. Again, it takes on a U. Nothing too surprising. Let's do the green one now. The vertex is still the same spot. The vertex is either the high or the low spot, and it's always the middle value in your table, or it's the middle of a quadratic function. Okay, just making sure I did that right. Oops. Excellent. And as you can see, what happens to the graph if I drew it completely correctly is that it opens up wider. In fact, you know what? Let me do that. At least I can get that right. Yes! So it opens up wider than the first graph. The vertex is still the same. It's still at 0, 0. But it opens up wider. It goes up slower is probably the way to say it. Since it's a smaller number than 1, it'll go up slower. If it's a bigger number than 1, do you think it'll go up higher, faster, or slower? And the answer is higher. But we did a negative number, so let's go ahead and do that in blue. And as you can see, this one explodes down really quickly. It goes faster. And the higher the number is, whether it's negative or positive, it's going to increase much faster. And if it's a number less than 1, it's going to kind of become a wider graph. Now, the domain and range for the first two are still the same. So I'll go ahead and write that down. Negative infinity to infinity. The range is from 0 to infinity. However, the domain and range are, well, the domain is the same for this one. But the range is different. It's from lowest value. It'll never actually reach its lowest peak, negative infinity, and it'll go as high as 0. That's the highest the blue one will go. So that's graphing quadratic functions with a number after the x squared and a number before the x squared. That's not an x term, mind you. And we're going to keep mixing and matching and see how it goes. Hopefully it's not too unpleasant. Later on, you won't actually even have to use tables to graph. And when I do these quadratic functions, I don't even use tables anymore, unless I assign it on a test, and I want to make sure my students do it. But after a while, I expect them to be able to graph something just by looking at it. With that said, have a great day for now. Goodbye.